CT, can you hear me?
Okay, okay,
I'll give you. Okay, could you share your screen?
okay, wait for a moment. Can you see me screen?
Yes.
Uh, so I
Uh,
start
you,
my presentation.
maybe you use a full screen mode, yes.
Yeah,
Yeah, and you know that you only have roughly 15 minutes to present, right?
yeah, okay.
Okay. Okay, so I let you start. You may start when you're ready.
Okay, okay, thank you. Good morning, everyone. It's a great honor to be here. I'm Siqi Wang from Jilin University, and today I would like to share with you our recent work on modally travel mode choice mechanism for SAVs, a multi-engine simulation of long-term behavioral adaptation under information influence. My presentation today is organized into six main sections. The first is the introduction. Let me start with a bit of background. As we all know, our current transportation systems face serious challenges: traffic congestion, energy consumption, and environmental pollution. According to the traffic statistics from 494 regions across the United States revealed that traffic congestion has resulted in 330 million gallons of waste fuel, 8.5 billion hours of delay, and 34 million tons of excessive greenhouse gas emissions nationwide. This is where SAVs come in. With their autonomous driving capabilities, they can maintain shorter interval passing and reduce speed variance. And because they are shared, they make better use of vehicle resources. But here is the thing. All of this only works if people choose to use SAVs. So what influence people's choice? In addition to the usual factors like individual socioeconomic attributes, trip purpose or trip travel time and cost, psychological factors like attitudes are now drawing more attention. And in our current age of information overload, attitude is heavily shaped by what people see and hear online, especially with new technologies like SAVs. People's acceptance levels are very sensitive to the surrounding information environment. So is there a mutual influence in relationship between information influence, psychological cognition, and more choices? Based on this, our studies aims to address the following three key questions. 1. Does information dissemination influence travelers' shifts in mode choice decisions? 2. If so, what are the mechanisms through which information dissemination affects travelers' psychological cognition and mode choice behavior? 3. How can policy intervention be strategically designed to maximize SAV's potential in enhancing transportation system efficiency, mitigating construction, and increasing environmental sustainability? To answer these questions, we first look at the existing literature. The first, the influence factors of mode choice. We found that the bidirectional link among information, attitudes, and mode choice are underexplored. Existing studies focus on direct effect but often ignore reverse influence. A holistic view is key to understanding behavioral adaptation. Second, mode choice behavioral analysis. Math. No studies have integrated multi-engine interactions and multi-day evolutionary and simulation into mode choice frameworks incorporating SAVs. This oversight poses a pressing challenge for SAV development as an emerging mobility option. Since there are two main ways of information dissemination at present, to understand how information dissemination affects travelers' attitude and mode choice, we collected two types of data. First, we conducted semi-structured interviews. We conducted personal background information and exposed participants to several rounds of SAV-related informants. According their mode choices after each round, in total, we gathered 72 valid response over 1 month. Second, we gathered real-world social media data from Weibo, over 2,000 SAV-related posts from 2024, including likes, shares, and comments. And what did we find? According to the interview, the attitude of most participants changed over time. Neutral views dropped sharply less than 1%, about 59% become opponents, and 40% become supporters. From the social media data, public attention towards SAVs was clearly influenced by big news and events and technology developments, showing how dynamic people's perception can be. We also looked at what factors were more correctly with SAV's adoption. The big ones were attitudes, trip purpose, original mode choice, and SAV speed and SAV fails. Further, the evolution of choices showed that attitudes are dynamic with more information exposure. People's views shift more sharply. The individual can be categorized into 5 types based on attitudes evolution. They are neutrals, varying supporters, and staunch opponents, varying opponents, and staunch opponents. Plus, the way people share information matters too. Supporters tend to highlight the positives. Opponents may distort or downplay positive information. Everyone plays both a receiving and a spreading role in the information network. To better understand this process, we built a model based on ideas from epidemiology. We modeled 5 stages. Neutrals are becoming varying supporters or opponents, switching between varying supporters and opponents, transitioning to staunch positions. We use differential equation to describe the dynamic and calibrated our model using our interview data, and then we fine-tuned it until the simulated results matched the chain of Weibo patterns. We then modeled mode choice behavior using Bayesian network and went 2 stages. First, traditional mode choice modeling. Second, SAV-specific decisions are based on psychological variables. To simulate how this behavior evolves over time, we built an engine-based model in NetLogo. In this model, one type of engine represents travel demand, defined by traveler and ship attribute. The other one represents travel mode, defined by speed and cost. Each simulation step represents 1 week. The key dynamics are the interaction between engines, especially how changing information affects attitudes and how attitudes in turn affect behavior. After several rounds of simulation, we analyze the simulation results and get some key conclusions. The first, the multi-day evolution process of mode choice. After analyzing the chart of simulation results, we found that mode choice isn't static, but after a long period of evolution, choices stabilized. The system reached equilibrium. The second, the multi-day evolutionary process of SAV propulsion. More positive information leads to faster SAV adoption. Greater SAV usage reduces private car use and boosts traffic efficiency. And SAV completely direct with taxi and online car hailing due to similar price and service. Although private cars will also be direct effect due to their large scale, the impact is smaller than that taxi and online car hailing. Public transit and non-motorized modes aren't affected as much. The third, triangular relationship of informational influence, attitudinal manifestations, and mode choice. There is a clear delay in how information affects behavior. Attitudes shift first, and then behavior follows. Also, positive information increases SAV adoption. Negative information has a stronger impact due to risk aversion. Too much negative information can significantly slow down SAV acceptance. The fourth, multi-day evolution of carbon emissions. Higher SAV adoption leads to fewer cars and lower carbon dioxide emissions. So the more positive information people receive, and the more they choose SAVs, and the lower the emissions. Finally, our research summary. To wrap up, let's revisit our three questions. First, yes, information does affect mode choice, and we confirmed the triangle of information, attitude, and behavior. Second, this effect follows a sequential process. Information change attitude first, then behavior. There is also feedback, especially experience affect what information people trust and share. And third, there are two main strategies. One of the information side, encouraging official media and key influencers to release accurate and positive messages, and emphasize that SAVs can coexist with current model, not replace them. The other one is about service side. Improve SAV quality through subsidized, dedicated, larger fleets, and rigorous safety testing. Both strategies are supported by our simulation results. This research provides a clear understanding of SAVs for travelers and a simulation framework to guide public acceptance for managers. And then we plan to refine the effects of different information channels and validate our policy suggestions through further simulations. Thank you all so much for your time and attention.
Thank you very much. I can see a question from Amelia. So can you see the question, or do I read the question for you? Can you see a
Okay,
question from my chat box? It is
uh,
about the emission. Uh,
wait.
so you actually discussed emission and environment. You have discussed emission and environment in your first slide. So how can SAV contribute to environmental sustainability, particularly in terms of emission? Can you see that one?
Okay, I see this one. Uh, Because SAV can maintain short inter-vehicle spacing and reduce speed variance, and they are shared. They make better use of vehicle resource. Uh, so they are been beneficial to environment.
But that may not be related to emissions, right? If you're using EV, electric vehicle, there's no roadside
Yeah,
emission.
SAV are all EV.
Okay, you assume all SAV are EV.
Yeah.
So if that's the case, there's no emission. So okay,
Thank you.
okay. So I actually have a 15. So I suppose you have 20 minutes. I have another question. Could you a bit more about what information you release to the traveler? What type of information? You keep talking
The
about information.
information
What type of?
about what kind of video and the picture and the chat.
Sorry, could you repeat it again? Could you repeat
Video.
video information on video? What video
Uh,
about the traffic condition?
about the about SAV's capability and the news about SAVs.
Capacity, you mean how many how many space available? Because it may be occupied. Some seat may be occupied.
Uh,
Do vehicle utilization or capacity? Because the capacity it can be fully occupied.
yeah.
So you talk
Uh,
about utilization usage.
The objective of this paper is not provide some information for travelers. It is our objective is provide scholars about or transport managers about how to manage SAVs, promote their service uh, better.
Okay, okay. So any other question from the audience? So I didn't see other questions. So if that's the case, then thank you for your presentation. I suppose
Okay,
there
thank you.
is a second speaker. So let me check whether second speaker is here or not.
Okay,
Okay, thank you.
thank you, thank you.
Junxia, Junsa. I'm not sure whether Junsa has been here because we are a bit early. Okay, Junsa is here. So roughly you have 15 minutes to present. So we are early. So you may decide to wait for 2 minutes before you start. Can you hear me? Junsa, can you hear me?
So far.
Hello?
Hello.
Okay, you can hear me, right?
Okay, I can.
Okay, so
Um,
uh, you roughly have 15 minutes to present. So we are 1 minute
yeah.
early, so it is better to wait for more audience to come before you start.
Thank you. Can you see my screen?
Yes, I can.
Oh.
My name is Junxia Wang. I'm very excited to present to you today on the topic of smart road testing rules evaluation method based on surrogate safety measures and fuzzy comprehensive evaluation. My presentation will be divided into 4 parts. First, we'll look at research background and significance. Then we'll focus on methodology, and more importantly, we will show case study on risk evaluation of smart road testing. Finally, we will wrap up with conclusions. Part 1 will focus on research background and significance. Recent crashes involving Tesla and Uber EVs have revealed that current autonomous driving technology is still immature, triggering widespread scripture about its readiness for large-scale deployment. Ensuring EV safety through road testing is now a shared technological challenge for academic and industry worldwide. Yet traditional test methods are insufficient to cover the long tail of real-world scenarios. Passively post-crash analysis are giving way to conflict-based surrogate safety measures that can identify hazards before collisions occur, but exciting SMF research mainly targets single vehicle risk. City-scale digital twins integrating high-definition maps and magnetic traffic data enable massive visual testing and high-fidelity scenarios simulation, offering a data-driven path to validate EV safety. With evolving safety standards and growing public scrutiny, regulators and developers urgently require comprehensive, transparent risk evaluation frameworks to justify long-scale EV deployment. Part 2 we will follow by methodology. This is the research framework. Given the risk evaluation background of smart road testing, a digital twin-driven risk evaluation framework was established. The framework consists of 5 layers: the physical layer, the twin model layer, the twin data layer, the data information interaction layer, and the application service layer. The study first established a digital twin-driven risk evaluation framework. Then micro and micro-comparison evaluation method for smart road testing risk, including evaluation method for operational safety risk and a micro-evaluation method for testing. This is a risk evaluation indicator systems and concludes of 5 parts. Based on the factors causing the road test risk, the Delphi method was used to construct the initial indicator system. First, 24 experts were consulted and each indicator was evaluated. After receiving experts' feedback, the indicator system was ended, deleted, checked, and modified, and a second round of experts solution was conducted. After the two rounds of expert consultation, the final evaluation indicator system was sorted out and formatted and shown in the figure. Diversified SMs can improve the fault tolerance of evaluations compared to single-type SMs. The following SMs are proposed for safety risk evaluation modeling. Followed by the Part 3, case study on risk evaluation of smart route testing. The Chengdu Economic Development Zoo Universe and Direct Link starts from Chengdu University and ends at Dong'an Lake May Stadium. Smart Road Integrated Management System is used as an enabling platform to build a new smart road perception management system that integrates people, vehicle, road, environment, and cloud. The actual map is captured using OpenStreetMap, and the location and direction of the canal can show in the left figure. The details of each section are shown in the table. The JE under relation method weight and ETROP weight method weights of each evaluation indicator are calculated respectively, and the combined weight is calculated. The results are shown in the three figures. The specific evaluation indicator level classification standards are shown in table. According to the weight of comprehensive indicators, the further comprehensive evaluation method is used to evaluate the risk level of the smart road test. The final calculation result is shown in figure. Since the map captured from OpenStreetMap official website is a smart part, there may be incomplete road network and discontinuous roads. After fine-tuning using GeoSM software, the resulting map is shown in the left figure. It's important into world builder of the Panasonic simulation software as shown in the right figure. The 6 subfigures in figure intuitively show the changes in these 6 items over time, where black marks represent low-risk methods and colored marks represent high-level movements. The calibration parameters of different items are shown in the table. Finally, we will show the conclusions. Our digital twin framework integrates micro-level operational safety risk and micro-level test risk, embracing holistic and proactive safety management for smart road testing. Micro results yield an overall risk score of 42, flagging high-risk interactions with pedestrians and commercial vehicles, thereby guiding trajectory safety improvements. Micro-analysis shows on 6 SMs can conduct longitudinal conflicts over 10 simulators in advance. However, multi-metric fusion is required to avoid the single indicator basis and to enhance practical accuracy. Okay, thank you for taking the time out of your busy schedule to be here. Please welcome to criticize and correct.
Okay, thank you for your presentation. So any question from the audience, if you have, please let me know. You can type your question or in the chat box or you raise your hand. So let me start the first question. So I see the word fussy evaluation method. So is there any sim method and why you propose this fussy method? Can you hear me?
Yes.
So I remember your slide show a word fussy. So why fussy?
Sorry, I'm conscious.
Could you show your slide? Could you show a slide? I remember you in your early part of your presentation, you mentioned a method about fuzzy matrix, something like that. Yes, exactly. Someone help me. Why using fuzzy method? Do you understand my question?
Yes. No, the physics method can evaluate the optional safety risk evaluation level and can combine the two methods.
I suppose there are other methods that can serve the same purpose. That's why I'm asking why fuzzy. Any advantage of using fuzzy compared with other existing methods? Do you understand my question?
Yeah.
No, you have no answer?
Yes, I agree this.
Could you elaborate more what do you mean by smart road testing? What do you mean by smart here? Could you make it more specific? How smart in your road testing? Hello, are you here?
Yeah,
Here?
the smart is so integrate people, vehicle, road, environment, and cloud. And it is used in the smart road scenarios.
Okay, I didn't see other question. Actually, I have one more question about calibration. How do you get those calibrated values? You have a table showing quite a lot of calibrated parameters. How did you get those values?
You see which one value?
You have a
And which
table.
one table?
You have a table showing a lot of calibrated values. I'm asking how did you get those values? From the field, from the simulation?
And the values come from simulations.
So you come from simulation. So, okay, okay. So, Marvin, are you here? So thank you for your time. I'm not sure whether the next speaker is here. Marvin, are you here?
Yes, I'm here. Can you hear me?
Okay,
Perfect.
yes. So thank you for the second presenter. Now, Martin is here, so you may start sharing your screen.
Yeah, I will do that. Can you see this?
Okay.
Right? Yeah.
Okay, I can see it. So, you may start if you're ready.
Yeah, perfect. 1 second. Okay. All right, then I will start the presentation.
Yes, please.
Okay, so thank you very much for attending my presentation. So the title about my research is Exploring Stakeholder Perceptions, Implementation Challenges of Shared Autonomous Vehicles. And this is a collaborative work from the University of St. Gallen and MIT. So what is it all about, or what's basically the motivation? So the motivation of this research is basically also as our first presenter about shared autonomous vehicles. So the age of autonomous mobility is actually happening. Robotaxis are already operating in many cities, for example, in San Francisco, but also in other countries and cities in the world. Here are exemplary videos of Waymo robotaxi service in San Francisco. As you can see, it's totally commercial. There's no driver on the driver's seats anymore. It's totally autonomous without safety driver. You can book it over an app. It's roughly the same price as an Uber, maybe like 5 to 10% more expensive. But yeah, it should just demonstrate basically that it's not a research topic anymore that's happening in the future. It's actually happening already today. However, at the same time, we also see pictures like that. Maybe somebody have noticed it. It's a picture taken recently in San Francisco at a hub where Waymo robotaxis pull out of parking spaces autonomously in the morning and then they head into the city. However, because of all the vehicles they wanted to leave at the same time, they often end up honking at each other and then waking up the residents who live around it. And they made basically a video and this picture. And it's just a perfect indication and shows very clearly that there are still some kind of implementation hurdles to overcome before SAVs can really be put on the road and commercial services can be offered. And this is exactly what we looked at our study. So the study was about implementation challenges. When we look into the research, what I found also with my co-authors was there's not much research being done on these challenges, on these hurdles of real SAV deployments. So for that, we did a previous study, which was recently published in Sustainable Cities and Society. And this was basically an integrative literature review where we tried to come up with a framework for preparing cities for the successful implementation of shared autonomous vehicles. And within this integrative literature review, what we came up with is the picture on the right-hand side, like a very comprehensive framework of lots of categories like infrastructure, policy regulation, and then you can go down the road into second level and third level, more accurate subtopics like physical infrastructure, roadway conditions, and so on. But what we felt like doing that integrative literature review was, firstly, there was not much research being done. So this is just 30 research papers that we kind of got the integrative literature review from. And secondly, none of the research has been done qualitatively, kind of speaking to the people who deploy these vehicles and what their challenges are. So that was kind of our research gap that we were looking into in. And for that, we also needed to know, okay, who are actually the stakeholder groups and how can we define them? So who are the stakeholders who deploy AVs or SAVs in cities? So we looked into the literature for that and kind of used the stakeholder identification. So there are three main groups. It's legislation and authorities, which is government, national and local authorities, road agencies. Then you have manufacturers and suppliers. These are the Waymos, the Apollo and Baidus of the world, but also OEM and suppliers of the vehicles, and also insurer and energy suppliers. And then you have transport operators and mobility providers. So these are the PTOs, these are the mobility service providers, and yeah, all the associations around it. Having done that stakeholder identification, we then used our research approach, namely we conducted a total of 29 semi-structured expert interviews across these different three stakeholder groups and also among continents to give a variety of information, basically. We had, as I said, 29 semi-structured interviews. We used an interview guideline and semi-structured one. 15 of the interviews were done with manufacturers and suppliers, 10 with transport operators and mobility providers, and 4 with the legislation authorities across the globe, with a focus area on Europe, but also quite a few in North America and some in only one in Asia. So it was a purposeful and snowball sampling method that we used. Then, since this is a very exploratory qualitative research, we used inductive coding, and we coded it via Atlas TI. We used the semantic analysis approach following Brown and Clark. And data saturation was reached after these 29 semi-structured expert interviews following Guest et al. 2016. The interview period was August 2023 to February 2024. The duration, the interviews ranged between 25 and 67 minutes, with an average of roughly 45 minutes per interview. And the transcription style was done in verbatim, and we had a total of 343 pages of transcription, basically. And then this is our main result. Basically, you can see it here that the main implementation hurdles can be divided into 5 major areas: technological, economic, regulatory, structural and organizational, and then social and behavioral. And these form so-called themes, according to Brown and Clark. So the first level of the last level of coding, it's basically the aggregation of all the code into sub-themes and then into themes. And these themes are these 5 themes. We can then divide them into a little bit more the supply side with the first 4 themes, and then the demand side with the social and behavioral. And these are the themes of the implementation challenges out of all our interviews and coding processes that we have done. When we look one level down and look into the sub-themes, you can see that there's 5 sub-themes within each of the themes, ranging from software-related technology maturity to approvals and licensing. Also, and this is quite interesting, the economic and structural organizational challenges, something like complexity, fragmentation, who's the operator and orchestrator. These are all sub-theme challenges, basically. And as a next step, and I'll do that just exemplarily for one of the themes. So here we are looking into the technical implementation challenges. And you have the 5 sub-themes, namely software-related technology maturity, you have digital infrastructure, you have physical infrastructure, safety and security, and then vehicle hardware, namely chips and sensors. And within these sub-themes, we have all the codes summarized here. And then you can even see from which stakeholder group this code comes from. Does it come from a manufacturer or a technology company? Does it come from an transit operator, or does it come from the legislation and authority, this sub-theme? Just to give an example, physical infrastructure, the middle one, we have codes like a need for physical infrastructure is mainly driven by regulatory requirements and standards, or updating existing infrastructure is beneficial for implementation of SAVs. Infrastructure is extremely capital intensive to change and therefore a hard challenge, and it requires city-level discussion on how SAVs can share space with all other road users. And in the paper, I will just skip over it very fastly. We have also done a sub-theme co-occurrence and theme documents analysis for all the themes. So you can basically see for the technical implementation challenges, for example, the software-related technology maturity, most of the concerns came from Europe and not from Asia or North America. And similarly, you can see, okay, the software-related technology maturity is also something that has been mentioned by players who mentioned regulatory or structural challenges. And you can do that for all, or in the paper, we have done it for all implementation challenger themes. Yeah, coming to the discussion and practical contribution of the study. So I will go over all the first 4 more, let's say, supply side challenges, and then have some recommendations for especially transport operators, and cities or legislation to cope with. So on the technical side, and major issues that a certain degree of new infrastructure, for example, connectivity, is needed, but it's very costly, capital intensive. So what is meant by that? So lots of the operators said you need a kind of infrastructure, for example, 4G or connectivity of the vehicles. The recommendation would be to pursue a frugal infrastructure approach and don't rely too much on it. Instead, leverage and update the existing infrastructure, which may be a little bit less capital intensive. Then the technology itself, the virtual driver, is for some regions or for some ODDs not major enough yet. And that's also why some of the players today, as we see with Waymo, also Apollo or Baidu, they go on ODD and then they go ODD by ODD and they get new areas and then they increase the areas basically with that. On the economic side, what we hear a lot was there's kind of a chicken and egg problem. So a lack of stakeholder commitment to buy vehicles or to implement them, and this inhibits scalability. So what's needed here is a collaborative kind of financial investment that's provided and a clear market guarantee or clear perspective. And this is actually also what you have seen during the last couple of months, which was not the period of this interview that I've done here, but if you look in the press, you saw a lot of Uber and Lyft articles that they kind of provided market guarantee and a clear perspective of buying 10,000s of vehicles of robotaxis from different vendors, which gives them kind of stability and it solves this chicken and egg problem. However, what's still kind of open is in a coexistence of or rivalry of different business cases and models. What's meant here is that many players or interviewees mentioned that robotaxis are different to robo-shuttles, and robo-shuttles are more public transport oriented. Robotaxis are kind of free in the city. And what we need here is kind of a regulatory toolbox that needs to lead and control also the expansion of these robotaxis. Otherwise, we have an uncontrolled scaling of these privately owned companies. On the regulatory side, we have heterogeneous local and hyperlocal approvals and regulations and a missing political will in some countries. We have a missing standardization and lack of L4 type approval vehicles and unsolved liability issues. And then the vehicles need to be safer than a human. That's a zero failure tolerance that most operators or also the people have. And we kind of, for that, we would need to raise the risk appetite. And some of the vendors, for example, Waymo, have already proven that they are much more safer than humanly driven vehicles, but still humans are kind of hindering it or kind of having blockade to use them. And for the approvals and licensing, we already have some first indications that standardization is made by industry guidelines, and there's kind of a current development of a simple process for L4 type approvals, but it's still not there. And then the structural and organizational challenges, these are very interesting because nobody in the past literature has really come up with these challenges. And they are meaning basically, number one is vendors following the doing it all approach, they may face many hurdles and start to disappear. We have seen that on the European market already happening. The recommendation would be to focus more on the core products and strengths that the market will naturally fragment. Therefore, you can see an entire SAB ecosystem, and you can see already today that it will kind of naturally fragment into these pieces where Uber is doing the customer relationships, and then you have companies like Beep who are doing the operation, and they are like key strength is this, and then at the end you have other players who are doing maybe the driving technology or the vehicles. However, people are still underestimating the complexity of reliable services, operations, and orchestration. So the entire SAV ecosystem is still kind of underestimated. And therefore, you need a joint industry push. You need partnerships and collaborations because you cannot fulfill the entire ecosystem by yourself. Thank you for your participation and interest in my presentation. And here's a QR code of the preprint. Thank you.
Thank you for your interesting presentation. I can see a question from the chat box. So it is from Feno Song. So can you see the question?
So in your opinion, for better operation of SIVs at the current stage and in the future, should more reliance be placed on road infrastructure or on the intelligent connected facilities installed in vehicles? This is actually a point where I mentioned with the physical infrastructure and digital infrastructure. This was very, let's say, in my interviews that I've done, it's like a 50-50. So when you talk more about the vehicle players and vendors, when you talk with them, they kind of mention a lot that they want to be self-reliant. So they don't want to be reliant on the infrastructure, because infrastructure is a heavy investment. It takes a long time because the cities need to do it. You have kind of a governmental and city approval process behind it, so you cannot change it very fast. And the companies want to scale very fast. So they try to, if you talk to Immobility or Waymo, they want to have everything in the vehicle. So the vehicle is as clever enough to drive L4 with themselves. If you talk to European players and also to operators, and some also where a vehicle or software players, they say in the long run, you need a decent amount of smart infrastructure to be on a very, very safe side. And maybe that's also a hindering point why we don't have any robotaxi and shuttle services yet in Europe, because they're developing the whole time. So it's kind of a 50-50 thing. It's difficult to give an answer because also the interviews were very indecisive in his in their output.
Okay. Thank you. So I didn't see another question. So, okay. Okay, there is a second question from the chat box.
Yeah,
Any
I haven't been
discussion?
really I was not able to go really deep into liability issues. And who's responsible in case of accidents. I believe it's the company who operates the vehicles at the point. So Waymo is doing that for San Francisco. But also for liability issues, I have, for example, mentioned there was mentioned in Europe a case when, for example, also an accident happened. Then there's a lot of process going on where you need to put your triangle behind the vehicle, 100 meter behind the vehicle. And this is not really possible, but because you have nobody in the vehicle, and the guest should not, or the customer should not be able to do that. So there's also kind of structural or organizational issues that come with that. But that's, for example, a law in Germany. So who's liable for doing that, basically? Yeah, but I was not really going into very hard detail into the liability issues. However, I mean, it's interesting that not many people have mentioned this as a big challenge. So I think this is not a real challenge to occur, because I think it's something that will be worked out via laws, and then this is set up. Yeah.
Thank you. So any other question? Yes, I can see the third question from Harish.
Yeah, so when I
Okay.
spoke to what are policymakers' perspectives on the potential job displacement caused by the implementation of SAVs in the transportation sector, I talked a lot with public transport operators on that and asked them. I didn't speak a lot with policymakers on that perspective, but I can give you an answer from the public transport operators' perspective. And these are basically the operators who deploy buses or metro systems and so on in the cities. And what they are telling me always is, look, for example, in Germany, you have until by 2030, you have a missing of 10,000 drivers. So that's a staff shortage. And even today, they are already feeling this because they have such a staff shortage on bus drivers that they need to cut their routing. So what they're doing currently is they talk about, okay, let's not put the vehicle like the bus route, it's not every 15 minutes, but every 30 minutes, because we're missing these bus drivers. So for them, they say until 2035, it's not really a job displacement caused by SAVs. It's especially when you look at robo shuttles, it's more over kind of a working against this shortage of bus drivers. And they said if the vehicle are homologated and licensed, we want to buy them because we need vehicles or we don't have any drivers and we want to offer the same services to our customers, but right now we cannot. But with these autonomous vehicles, we could do it. Yeah. So I think the job displacement is not so badly or negatively accused in most of the people's and PTO's beliefs. Yeah, as Giancarlo's also mentioned, in Japan, it's the same. I think in US it's also the same. So and when we look at the current numbers of Waymo, Apollos, and so on, I mean it's great what they have achieved, but WeRide, Chinese company, Apollo, which is the Baidu-owned robotaxi company, and Waymo, they have each 1,000 to 1,300 vehicles on the road currently as we're speaking. So we don't talk about huge amount of number of vehicles yet. However, it took them 2 years for the commercial implementation and scaling. So 2 years since they're commercial available, and they scaled to roughly 1,000, 1,300 vehicles. So it's not a huge deal, I would say, yet. So it also takes some time, and the shortage of drivers, it's also occurring fast. It's already happening today, and in 2030, 2035, it's going to be really bad.
Okay, thank you. Because of time, I have to stop the Q&A section. Thank you very much.
Thank you.
Thank you. So may I invite the next speaker, Masahiro Kao, Masahiro.
Hi, can you hear
Okay.
me?
Yes. You may
Thank
start
you.
if you are ready.
Yep. Can you see the screen right now?
Yes, I can.
Thank you. Thank you, Session Chair, for the introduction, and I would like to thank everyone gathered here for coming to listen to my presentation. And I would also like to express my gratitude to those involved in organizing this BTR conference, having experienced several times how lack of money and funding can hold research. I deeply appreciate the value of such a wonderful conference. Now, let me begin my presentation titled Metropolis-Hastings Sampling of Individual Schedules. The structure of the presentation is as follows. And the importance of utility-based, agent-based model for understanding behavior remains unchanged. This is because white box or gray box model are required to clarify interpretable principles of behavior. Even though we are in the era where machine learning and LLM have advanced significantly, this importance never changed. And one of the latest approach in ABM is OASIS approach, which integrate the representation of entire schedule within a utility maximization framework, encompassing departure time choice, stay duration choice, destination choice, mode of transportation choice, and more. And the characteristics of this approach is various constraints, such as spatial temporal constraints, can explicitly represent it. The figure on the right show all the possible schedules that can be represented using this approach. And the specific sampling method is also important because in scheduling models, it is impossible to enumerate all candidate schedules as options. So sampling is needed. And McFadden et al. 1977 and others have proven the asymptotic properties when correlation terms are included. On the other hand, many researchers show in practice using importance sampling result in smaller bias and variance. To design reliable urban transportation policies, it is essential to ensure sufficient reliability in the estimated parameters that serves as references for these politics. This is the motivation behind conducting this type of research. So in this previous research, we propose a sampling method using the Metropolis-Hastings algorithm, a type of MCMC, or a type of importance sampling for a group of models that integratively represent schedules that with the smaller bias and smaller variance of estimated parameters. And we identify the essential state transition operations in the MH method and proved that by using these, the resulting MCMC satisfies theoretical guarantees. So due to the time constraint, I will skip the explanation of the ABM activity-based model survey. And here is the survey on the estimation of choice model with sample of alternatives. As I said, McFadden et al. Demonstrate that in the ML, even when using sampled alternative choices, asymptotic properties like asymptotic unbiasedness and asymptotic efficiency of the estimated parameters are satisfied when using McFadden's correlation factor. And other paper like Guevara and Ben Akiba, 2013 A and B provide similar proofs regarding the logistic mixture models and the MEV models. However, caution is needed. With finite observational data, asymptotic unbiasedness and asymptotic efficiency are not guaranteed. That is why the sampling method becomes more important. Many studies report that the important sampling results in smaller bias and variance compared to simple random sampling. Especially in schedule models, the complete choice set size increases exponentially, and this trend is increasing. So here is a related research which shows this trend. And I would like to highlight the importance of importance sampling by discussing a specific study. This is Lemp and Cockerman, 2012, which shows the importance sampling. In this figure, the first column displays the bias here and or here or here is the bias when using random sampling, while the second two fixed columns show the bias when using importance sampling. It is very clear that important sampling shows smaller bias compared to simple random sampling, and the same result are observed for variance as well. And the same results is observed in all the other studies as well, which I showed in this table, table 1. So, when we try to use MCMC method, which is the most sophisticated importance sampling method, there is a existing studies on root choice and activity-based model. But MCMC is theoretically guaranteed to work properly if and only if the following two conditions are satisfied. The first one is balance condition, and the second one is ergodic condition. And the ergodic condition is further composed of three elements: reducibility, and aperiodicity, and positive recurrence. Previous studies have made excellent proposals using the MH method, but the theoretical proof was not sufficient, so I tried that. This slide is a repetition of the previous one, which shows the contribution of this research. So I would like to move on to explaining the proposed method. As I said, we use sampling MCMC method to sample target, and the sample target is individual schedules. Specifically, the dimension of the schedule of or the state space include time, location, and mode of transportation. And as assumption, the period is divided into discrete time units, like 5 minutes or 10 minutes or 30 minutes or so. So it is necessary to sample only feasible schedule that satisfy spatial temporal constraints. For example, states schedules that do not match the analysis time frame are infeasible, obviously. For example, a day not totaling 24 hours, or states that are not spatial temporally continuous are infeasible too. For example, warping is not allowed in this physical world. So we use Metropolis-Hastings algorithm. This framework of the MH method is very general one, and we follow the overall structure of the important prior study by Pogara et al. 2023. And the balance condition is easily guaranteed. And this condition is a sufficient condition for comparison to the target distribution of Markov chain. And many MCMS methods, including the MH algorithm, satisfies the more straight detailed balance condition. Specifically, it means that the equation shown in the middle of the slide holds true, and it is easy to satisfy. However, the proof of the ergodic condition is by no means trivial. It is a condition for the Markov chain to converge to a stationary distribution. And as I said, it means that all three conditions, irreducibility, periodicity, positive recurrence, are satisfied. It is necessary to appropriately design the state transition operations in the MH method. And the formal definition of the ergodic condition is given by the theorem shown in the bottom of this slide here. So we propose 4 state transition operations in MH method. We found that these 4 have been identified as essential for proving the ergodic condition. And the key point is to ensure transition occur only between feasible states while considering spatial temporal constraints. If you would like to know the details of the equations, please refer to the journal article that will be submitted soon. I want to skip the detail because of the time constraint. And let's move to the proof of irreducibility first. Simply put, this means being able to transition between any state, any scheduling candidates. And intuitive visualization of this property is as follows. In this figure, each circle represents a state of the Markov chain. It means a state. The state is as one schedule. So the left-hand side shows an irreducible Markov chain, and right-hand side shows a reducible Markov chain. So if the system is irreducible, starting from any candidate schedule and applying transition operations, it is possible to reach any schedule. The formal definition of irreducibility is as shown at the bottom of this slide here. So to prove this property, it is possible with the 4 essential operations by applying the following 2 strategies. First, passing through a special state Z here, state Z, where one stayed at home throughout the analysis period. And the second one is carefully designing the order in which the 4 operations are applied. And I show the main flow of the proof of irreducibility here. From any schedule, we can reach to the state Z a schedule where one stay at home throughout the unsafe period, and from that state date, we can reach to the any state or any schedule by applying the 4 essential operations. And the detailed proof process is as shown here. Due to the time constraint, I would like to skip it. And let's move to the second property, periodicity. To put it without fear of misunderstanding, it means the states can be randomly mixed. The visualization is as follows. And as I said before, each circle represents a state or the Markov chain or one schedule. And on the left-hand side, the aperiodic Markov chain are shown, which is starting from any state the system can mix randomly. But on the other hand, when the periodic bad condition, the Markov chain cannot be mixed well. So here is the detail of proof. And the key point is that in the MH method, the acceptance rate can be less than 1, which means it is possible to stay in the same state. And this key point is the foundation of this proof. But I will skip this part. And the last one, the proof of positive recurrence. Simply put, it means returning to the same state after a finite number of transitions. And the visualization is here. And only in the positive recurrent Markov chain from any state, it returns within the finite number of times. This is the third property of ergodic conditions. So looking back at this proof shown in this research, we can discuss 2 topics. The first one is the constraint-related modes of transformation can also be addressed by making a slight extension. Specifically, I mean the spatially continuous continuity of privately owned POV should be taken into consideration. And I found that these constraints can be handled simply by expanding the state space and state transition operation, as I showed before. And the second one is much more interesting, and the insights have been gained regarding the acceleration of mixing in MCMC. And this study revealed that only 4 operations are essential. I mean, these 4 operations are essential. But as a result, it was found that conversely, some previously proposed operations, swap or meta operations proposed by Polgara et al., are not essential themselves, but since their combination of these 4 essential operations, they actually serve to accelerate mixing in MCMC. I think this finding is interesting. And here I show the future works. First, I want to verify through simulation. And second one is proposal of household level schedule generation algorithm. We are working on that now. And the third one is a bit more difficult, but consideration of correlation between schedule is needed. And research on scheduling model itself that incorporates such algorithm as component will be done. And here is the summary. And as I said, mentioned before, to design reliable urban transportation policies, it is essential to ensure sufficient reliability in the estimate parameter. And this work will contribute to that. And this proof serves as a foundation for the future extension. The references are listed on this page as shown. And thank you for listening. We welcome discussions and collaborative research, so please feel free to contact us. Thank you.
Thank you for your presentation. So if audience have any question, please feel free to put down your question in the chat box. So up to now, I didn't see any. So this one is quite theoretical. So I just wonder, actually, if I understand correctly, you are actually modifying an existing algorithm, right? By relaxing some assumption, right? Because from the title of your presentation, it seems that there already an MH algorithm. My understanding is that it seems that you relax some of the assumption of that algorithm and then you prove it and then extend it for another case. Is that correct?
Yeah.
Okay.
So,
So
yeah,
yeah.
go ahead.
Continue. So if that is the case, I would suggest that when you submit your full paper, you better to modify your title a bit. Because from the title, I didn't see the contribution. But it seems to me that you actually an enhanced method. It is an enhanced method or relaxed method of the existing method. So I didn't see any keywords about enhancing or relaxing in your title. The proof seems to be very rigorous, but I just want you to highlight the key contribution in the title a bit.
Thank you. I will reflect your suggestion to when I submit the paper. Thank you.
Okay, thank you. So I still didn't see other questions. So if that's the case, then thank you for your detailed presentation. Thank you very much. So I think Ziwei is here. The next presenter Ziwei is here. So you can start sharing the slide.
Okay. And could you see my screen?
Yes, I can.
Okay, then I would like to start. Oh, sorry.
Yes.
Okay, hello everyone. It's my honor to present our research that the immobility or soft refusal. We want to validating the impact of diligence on immobility reported in the household travel survey. So for the household travel survey, recorded the trip and personal information of each household unit. And what is soft refusal? It indicates the travelers answered immobility. This in the household travel survey to avoid the response burden, even if they actually traveled on the survey day. Instead of just dropping out from the survey. So why we have to consider the soft refusal? Because it will cause critical bias and sometimes the estimation of the travel demand. The data quality of household travel survey is critical for the transportation planning and behavior modeling research. So there is evidence that the possible soft refusal may exist. The right green point indicates the mobility rate of the Tokyo person trip survey, and the gray histogram indicates the corresponding time use in Japan time use survey. And we can see that the reported mobility rate of the person trip survey is always lower than that of the corresponding time use survey. And the gap between these two survey is increasing. So we have to consider the soft refusal. Actually, there is a important research pointed out that the immobility rate of one-day household travel survey should be between the 8 to 12%, but this value is pretty much higher in the household travel survey in Kumamoto, Japan. And there are some researcher want to find the possible soft refusal. They use the speeding, which means that the people answer the question too quickly. And the streamlining, it indicates that people give similar answer to a series of a question, which consists of the straight line. And also, they also use the biological model to detect possible soft refusal. The people who are predicted as the mobility but reported immobility are considered as the possible soft refusers. And there are also in some panel household travel surveys, the people who quit from the survey waves may have made the possible soft refusal in the previous survey waves. But there are some research gaps that the soft refusal indicators for the paper-based cross-sectional survey are still is not enough, and there is to address this, there are some non-household travel survey research found that the diligence of the respondents would impact the response quality of the made to the survey. So in our research, we want to investigate the association between the diligence and the possible soft refusal. So we get a basic hypothesis that the non-diligent respondents are more likely to make soft refusal. So who are non-diligent respondents? The first is item non-respondents, which means that the people skipped some questions. And we picked 3 items, which are the household income, monthly activity frequency, and travel frequency of weekdays and weekends. And the next indicator is a non-reporters on open-ended question. In the supplemental survey of the household travel survey, the respondents are instructed to answer an open-ended question to share their expectations to the local transportation system, but many people didn't answer this question. And the next is the proxy respondents, the people who didn't answer the questionnaire by themselves, but by their household members. And the next is the late respondents, which means the people who submitted their questionnaire after the deadline. And the last is incentive seekers. In the web-based survey, in the Kumamoto household travel survey, the respondents could apply a 100 yen coupon to as the incentives. But we suppose there are some incentive seekers will give a bad quality response just in order to just obtain the incentives. So they are more likely to make soft refusal, which means that their immobility rate will be higher than the diligent counterparts. The data we used is 2023 Kumamoto Metropolitan Household Travel Survey, and the survey period is October to November in the 2023. It's a 1-week-day trip. And for the sample size, we have almost 30,000 valid samples. The target sample are the people aged 5 and older. And the survey methods are consists of the mail-based and web-based. Actually, this is chosen freely by the respondents, but please note that online web-based respondents are eligible to apply for the incentives, which is a coupon of 100 yen, approximately $0.65. The information of the Kumamoto household travel survey includes the socio-demographic attributes and some trip information. And there is also another add-on survey. It collects the weekly travel frequency and monthly travel activity frequency and an open-ended question. So as a result, we found that the item non-respondents and non-reporters on open-ended questions and the proxy respondents are more likely to make soft refusal because their immobility rate is higher than the corresponding diligent respondents. And the difference in immobility rate is statistically significant. But there are still 2 indicators are opposite to our hypothesis. The first is the incentive seekers are less likely to make soft refusal because they reviewed the lower immobility rate than the non-incentive seekers. And the next is the response punctuality is not a significant factor because the immobility rate of the on-time and late respondents are very close. For the incentive seekers, we can find that they show higher immobility rate than the corresponding incentive seekers. But if we look into the age group, the difference in immobility rate is only significant among the minors. So we can say that maybe the 100 coupon could motivate their parents to provide better proxy response for their minors because the trip of the minors is very easy to report. They mainly travel between the school and home, and the departure time and arrival time is stable than the discretionary trips because how to say the most response of the manners are proxy response. And for the submission time, we can find that although the difference in immobility rates between the late respondents and on-time respondents are significant, but their value are very close. And if we look at into each age group, the difference between the late respondents and on-time respondents are not statistically significant. So we could say that the submission time may be not a significant factor to the possible soft refusal. For the immobility statistics, we checked the diligence indicator one by one. So we want to use the model to comprehensively check their impact on the reported trips. For the baseline model, we incorporated the factors that are generally considered to have impact on the mobility, such as the gender, the age, the occupation, but the weather are deleted because the weather condition in 3 survey lots are very close. So, and next we build a diligence diligence adjusted model. We incorporated the diligence indicators to the variable sets of the baseline model. If their coefficients are significant and in the expected direction, they have impact on the reported immobility. And here are the results of the baseline model. Although our objective is not to discuss discussion of the coefficients of the baseline model, but the most variable are in the expected direction, such as the younger people, the people who have accessible car, and the people lived in the downtown area are more likely to be mobility. And here are the results of the diligence indicators. You can find the directions of the coefficients are as same as the immobility statistics, except and we can see that the response time is still not a significant factor. And the item non-respondents and open-ended question response is the two most important fact indicators. After that, we did a scenario simulation that we estimated the immobility rates when diligence changes. So why we want to do that? First, we want to measure the impact of each diligence indicators on the immobility rate, and also it is a possible approach to correct the possible soft refusal bias. So we have 5 scenarios. So the first is adjust the item non-respondents to the corresponding reporters. It is very easy. So the next is make the proxy respondents to the corresponding self-respondents. But according to the Peter Stoffer, that the proxy response is inevitable for the younger people and very old people. So we only change the samples age 20 to 85. And the next is that we found that the web respondents, even the non-incentive seekers, are more likely to report the immobility than the mail-based respondents. So we transferred them to the mail-based respondents. And the next is that at least one reporter of the open-ended question in each household. And the last scenario is that the scenario integrated scenario 1 to 4 to analyze what immobility rate should be. And the original immobility rate of the matched samples is higher than the 21%, but the corrected immobility rate in scenario 5 decreased more than 5 percentage point, but it is still higher than the benchmark proposed by the Marjorie of the 8% to 12%. This may caused by the pandemic COVID-19. And for each diligence indicator, there are 2 effective improvements that ensure every household answered the open-ended question. and transfer the item non-respondents to the corresponding reporters. And there are still two optional improvements that the web-based response is acceptable and transfer to the proxy response to the self-response. How to say, the web-based response and proxy response could be acceptable to collect more samples with a small cost, but we suggest to estimate the trip adjustment factor for these two kind of survey methods. And here's some takeaway message. And thank you for listening.
Okay, thank you for your time and presentation. So any question from the floor, if you have, please put it in the chat box. So I'm not sure whether there is a question. So is that question related to the previous presenter or the current one? Against Carlos. So is your question related to the last presenter or the current presenter?
I'm sorry, would you like to repeat again?
No, I see a question, but I'm not sure whether this question is for you. So that question is from Carlos. Okay, that question is for the previous presenter. So up to now, I didn't see any question for your presentation. I'm not sure whether I understand your presentation correctly. So there's a proxy response, right? How come there is a proxy response?
Oh, okay. In the household travel survey, everybody will get a questionnaire, but there's somebody didn't answer the questionnaire by themselves. That their parents to answer the questionnaire for them.
Okay, so that's why you are not sure the answer is true or not, because it is not filled by the person himself or herself. Okay.
Yeah.
Okay. So how did you deal with that situation then?
Actually, in the data set we use, we can know whether the response is proxy response, and we also know who answered the questionnaire for them.
Okay, so if you know that it is a proxy response, then how did you modify the analysis or modify the conclusion then? Because still you don't know whether it's true or not true.
Yeah. We don't know the ground truth of the proxy response. Yeah.
Yeah, you don't know. Okay. Okay, so I didn't. I didn't see any other question from the audience. So if that's the case, thank you for your presentation again. Thank you for your time. Bye bye.
Bye bye.
The last presenter, Li Wen, I am sure you're here. Yeah.
Hello.
Okay.
Do you see my slide?
Yes, I can.
Okay, thank you.
Okay, you may start if you're ready.
Okay. Sorry, I took this one. Okay. Hello, everyone. All right, check this. Okay. Sorry, do you see? Okay.
I can see the slide. You may start now.
Okay. All right. Hello, everyone. I'm glad to have this opportunity to share our research topic. Our research is exploring the association between the built environment and the elderly driver's license return, evidence from Kumamoto, Japan. I am Li Wen Chen, and we are from Kumamoto University. And Many countries face the challenge of ensuring safe and accessible transportation for their aged populations. In Japan, there were the same problems. In Japan, there were 34% over 60 who are over 65 years old to involve in fatal traffic accidents. In order to solve this quick problem, Japan has a voluntary return of driver's license. If you return your driving license, you can get the free tickets for taxi or bus and so on. Okay, after reading this literature, we got some factors and research method. Factors including personal, social, policy, economic, environment. And their methodology used a questionnaire survey and a descriptive choice experiment. So we find a gap and needs. In our study, in our research, we use GIS data and the 2023 Kumamoto person trip survey data to analyze the built environment's impact and the demographic and the travel patterns on the driver's license return in different regions. Okay, in our methodology, I would like to introduce the data, 2023 Kumamoto person trip survey data. The survey area including 5 cities, 6 towns, and 1 village. You can see this map within the Kumamoto metropolitan area. And the survey period is from 2023 October to November. In our research, we just take the samples who are over 65 years old and they complete the whole answer. So in our research, there are 5,300 to 28 samples. Okay. Our dependent variable is driver's license return or keep. It means yes or no. And our independent variables are 24 items. Let's separate 2 parts. The first part is built environment, including destiny, diversity, design, destination, accessibility, distance to transit. And the second part is demographic and the travel pattern, including gender, age, do you have a job, do you have income, family size, and including the shopping frequency and hospital frequency, entertainment frequency. Okay, in our research, we use we took GIS data on QGIS software. We took overlay analysis and the neighbor analysis. The first picture, we can see the green means forest, the red means building area, and the sea and the road. But in our research, we just take the percentage of building. So we from this table, from this picture to know the data. And the second picture is the location of bus stops. We download the data from 4 bus companies in Kumamoto. So we know the location and the numbers of bus stops. The third picture means the public service facility. Public service facilities, including a library, police office, school, hospital, and so on. In our research, we only count the numbers, so we can know each area how many in this area. In our result, at first is descriptive statistics. For driver's license return rate, average driver's license returns rate for older adults is 13.06%. And we can find they are most concentrated in the central area of Kumamoto City. And average job rate for older adults is 32.75%. People who are employed are mostly in the outer towns. And the average family size for older adults is 2.09 people. And we want to know the living alone rate per each zone. So we do this analysis. Areas with a higher proportion of people living alone are mostly concentrated in the central area and Kumamoto City. In our research, the average age for older adults is 71.74 years old. Those age 75 and over are considered to be in late old age from the distribution. In this chart, we can see the areas with a higher proportion of late elderly samples. We took the binary logistic regression, and we got the R square is 0.4722. Out of the 24 variables, 40 are statistically significant. I will explain it detail in the next page. Okay. You can see the number of bus stops in the place of shopping and the distance from home to hospital. If they are more, they are more likely to return driver's license. But if distance from home to shopping, the distance is more, they are willing to keep their license. And if you are female, you are older people, you have higher income, your big family size, and you have mobility scooters in your family, and you don't have mobile device, you are more likely to return your driver license. And if you have a job, if you have a car for in your family, and you are more shopping frequency and entertainment frequency, and you don't have problem using public transportation, you are more likely to keep driver license. Okay, in discussion, we found related papers in 4 fields that support the significant findings of our study. The first part is factors for using a car or public transportation. The bus stops numbers and near the shopping, and the gender, occupation, income, and the family size on cars, technology adoption. We have the same results. They are significant. And the second field, psychology and the behavior of elderly driving. Public transportation problems, age, scooter entertainment frequency, well, the same result. The third field is shopping-related travel patterns, about the distance of shopping and the frequency of shopping. The 2 variables are significant. The last field is return your driver's license. The occupation is the same result. But there is one variable for which we couldn't find any directly related research to support it. Hospital distance may affect the transportation dependence pattern of the elderly. Future studies can further explore the interaction between this variable and the health status. Okay, conclusion. So if someone more are willing to keep their driver license, maybe they have a job, they have their income, they have their own car, they have their demand for travel convenience, they are limited alternative mobility options, and someone will likely to return their driver license because they have family support and the mobility scooter ownership, and they are female or older people, and the accessibility of alternatives. So we put the keywords into AI and image generation. So we got the people someone will like this man. It will maybe they keep their driver license, and this woman's likely to return their driver license. Okay, in the future, we think the public feasibility, because in our research we just take the numbers, but different types of public feasibility maybe have different meanings for people. And the second is psychology health status, because the impact of psychology health status on returning a driver's license, and the variables between the variables, the international terms in the model. And then the last is monitor changes in older adults driving behavior over time. Okay, this is our reference. Okay, thank you for your listening.
Okay, thank you for your presentation. So if the audience have any question, please put it in the chat box so that we know that you have a question, or you can raise your hand using the function inside Zoom. So I just have a quick question. So on page 12, mention scooter. One of the bullet point mentions scooter. Could you show page 12?
Sorry. Okay.
12.
12. Okay.
So one of the point about returning license is about family support and mobility scooter ownership. So why you particularly consider scooter a product for more elderly? So I don't really see why the elderly we consider scooter. Scooter is
Scooter. As a mobility scooters means like this picture, like okay, this old woman use this.
okay, not the common scooter we thought about. Okay.
Yes. Thank you.
Okay. Okay. Any other question from the audience? Okay. Seems not. So if that's the case, I would like to conclude this section. Thank you everyone for joining this section. Also, thank you all the presenters for their presentation. Thank you very much. That's the end of this section. Thank you.
Professor, thank you so much for chairing this session.
Oh, thank you. Thank you.